Okay. So some quick notes. We are recording this. Everything goes to community pipeline.ai/community. Thanks for joining. We have a lot of people on. Love to see it. This is Chris Fregley broadcasting this week, or actually early this week, today out of Copenhagen. The rest of this week I'll be in London for the Deep Learning Summit. I have some slides on that stuff later. So I want to give you guys a quick overview of some of the latest pipeline stuff, some of the research that we've put in to Community Edition. Also some bug fixes with the open source. So let me just do a quick agenda slide here. This is, well, anyway, yes, I'll just go through it. So a couple quick notes since the last time. We've actually been putting together quite a few slides and getting some cool stuff, out of our heads and into slides and white papers and that kind of thing. So we actually have a white paper that we haven't yet posted. Let me find it here real quick. Let's see. We've got about 10 white papers in the works here. The one I'm going to show you guys is, let me see here. We actually have a PipelineAI product brief. Makes us look like an official company, like a real company. So people have been asking for this, and just kind of explains the challenges that Pipeline is here to solve. And let's see. Okay, let me just make sure everyone can hear me. Can everyone hear me okay? Because part of the Zoom was telling me that they couldn't hear me. Okay, so we're in good shape there. So these white papers will be posted to Pipeline here probably either later today or tomorrow. We have a bunch more in the works. Let me just give you guys kind of a preview, talking about canary models and sort of education around things you should know about production AI. Also the Amazon installation guide, Azure installation guide. The fact that we have embraced Kubeflow and we are using parts of Kubeflow where we find that it's the best in class. For other stuff, we have our own proprietary solutions, and some of that is in the open source. There's also, various kind of competitor analysis, things like this that we want to be transparent about and, talk about the other companies that are in this space. We also have a performance guide. I want to actually give you guys a quick hands-on with that. This is more just kind of slideware here, but we'll actually do this here in a bit where we will load up the Community Edition. We'll compare GPUs to CPUs. We'll compare Scikit-Learn to TensorFlow, XGBoost, just straight up Python, and all doing the MNIST data set. Okay, so let me go back to the actual webinar slides here. So one slogan that we've kind of latched onto here is trust your AI in production. And this is really that kind of safe feeling of putting your ML out and being able to canary test your models. And we actually can generate hundreds of variations of your model by combining runtime like performance enhancements with model enhancements. And there's this phase between model the modeling and model training, and then the actual productionization that Pipeline's trying to highlight here. So in kind of digging up some of the numbers, by 2021, IDC is estimating $59 billion in AI application spend. Currently, this is, I believe, $17 billion for the year 2018. So nice triple 3x factor here. We've also kind of started, rather anchoring ourselves to some of the more successful players, and these have been pretty good exits, like AppDynamics and BEA. These were public companies. or I think AppDynamics was just about to go public. But I used to work for BEA WebLogic back in the day. That's where quite a bit of my enterprise network comes from. And so we're really, the sort of middleware for ML applications. And that's something that seems to be pleasing to people's ears because it seems to sit well. Also, there's this notable quote. This actually came out earlier this year, and we're capturing this and kind of highlighting it as part of the company mission, which is model inference is hard, right? That's a common statement, but we're also backing it up, and this comes from the CEO of NVIDIA. They're tripling, quadrupling down on the sort of inference side of machine learning versus the like training side. And so beyond, just normal latency accuracy, these are things that are sort of systems level things, but there's also the rate of experimentation, which is super important from the business side of things, where you could try out like various like model variants and also performance and different runtimes, specifically like the NVIDIA TensorRT runtime, which is one of the options within Pipeline. Okay, just want to also, so kind of building on the rate of experimentation side of things, if you can wake up in the morning, think of a new idea, and come to work and push that model out, by lunchtime, factoring in maybe half a day for model training, full day for model training, and then push that out. That's super powerful, right? Like versus waiting, 2 weeks, 4 weeks for it to snap into the application like development cycle or the ML engineer cycle, the sort of unicorn bottleneck we call this. And so, to keep differentiating and to sort of like maintain dominance, these enterprises need to like respond to things continuously, right? Like fraud, bots. So doing things like trending now and sort of, real-time recommendations, these are super powerful. And if you don't have these, you're sort of always behind. You will always be, 48 hours behind, 72 hours behind when your Spark job or your Hadoop job is done telling you that you have fraud, like versus the ability to catch and like recognize this right away. So pretty much all solutions to date are research-focused machine learning solutions. And, this is unfortunate. There's a lot of, crowded space here, and there's not a lot of folks that are focusing on production level engineering for machine learning. And it's really the, powerhouses like Facebook and Google, right? Like these folks, right? Like Netflix, they're doing this like real-time engineering with their AI. So current solutions either are like bespoke one-off solutions, they're slow, they're offline, trying to do things online, with a set of features and a base architecture that's really meant for offline. So, classic would be trying to do Spark ML. And doing that online, but still being bound to a Spark cluster. And, this is just a horrible practice, or trying to use even Kafka for like request response type things, right? These are just, it's trying to fit like a square peg into the round hole. So just be careful if you have the intuition, like we're all pretty like sophisticated, right, like engineers here, and we understand that something, if it's not working right away, or if it doesn't have a good feel to it, that something's wrong. And that's what we're seeing quite a bit of, and that's why Pipeline exists, is to create a base architecture and base platform that's specific to production type engineering for AI. And so we see quite a lot of these like one-off solutions that either have like a manual component where you're manually trying to rewrite these in C, from Scikit into C, or from R into Java, something like that. There's a lot of room for error. These are costly. These are not scalable. There's always the ML engineer bottleneck. These are inflexible. There's no way to really automate this or inject any kind of smartness to it. And then the other thing too is like this is one way. So there's not a lot of feedback going on. We're basically just always kind of behind the 8 ball, pushing these models out. And so that's the problem that Pipeline's solving. So here's a solution. we claim we're the only ML application platform built for the continuous real world. So the real world here has things happening all the time, and these aren't bound on 24, 48-hour sort of discrete, and that's how we've been thinking up till now, because those are the tools that we've had at our disposal. So now there's a new platform, and that's where the PipelineAI stuff comes in. So this is really 360-degree feedback. This is happening nonstop from the research lab to the application engineers. It's more than just an automation, because we're actually generating multiple variants. And this is super powerful. So I'm going to highlight this here in about 2 slides when we get to the actual hands-on demo. Let's see. Yeah, also safe. This is dynamic platform. We can push out hundreds of these generated variations of your model into production that are either different implementations, Scikit into TensorFlow, or Java into C. So we can actually generate these things for you. If you have access to GPUs, we can also generate GPU versions, and that's really where the secret sauce comes in. And then the ability to get all of these out in a safe and shadowed mode, which is one of our white papers coming up here, is this concept of a shadow canary. So this is something we did quite a bit at Netflix, and since then we've been frustrated that that there are no solutions for this, and sort of mixing machine learning with high velocity microservice deployments and experimentation. And so here's the traction so far. So we have about 3,000 GitHub stars. There's 120,000 folks that have expressed interest in this platform. We do, tons of these webinars, not just this monthly one, but we do stuff through the O'Reilly media, and we host a lot of meetups throughout the year. Yeah, I'd say over probably 120 of these speaking events, between the meetups and conferences. And also, we're approaching about 100,000 for the global meetup, which some of you probably found this. And the cool thing about these contacts, there's power in these numbers, and we get a lot of feedback from these folks. It's pretty much a third ML engineers, a third application developers, and a third data scientists as sort of their day-to-day job. And that's exactly the split that we were hoping for, because the platform is really meant for all 3 types of these engineers and scientists. So some good stuff that's coming here. Okay, and then in terms of the actual product, we offer the community edition. We just launched the European version, which really is pretty much the same as the community, with some extra GDPR stuff thrown in there that's living on separate servers and separate parts of Azure and Google and Amazon Cloud to keep the data in those regions. We have Professional Edition, which is kind of the next step up, and then of course the Enterprise, which is a bit more high touch. And a few highlights here. So auto-generating new runtimes. Also, we're a unified, sort of runtime for all the various frameworks. So you could still use R and push an R model out. You could still use Scikit, push a Scikit model out. But I'll show you how we could actually generate new versions here. Also, when you're experimenting live in production, one thing that we had at Netflix that we built was the ability to roll back things quickly if something's going wrong, or flip it from live mode into shadow mode, so we could just shadow traffic. We could also scale out, models that are actually winning. If we're, pinning 100 different variants versus let's say 100 different challenger models versus the single champion model that's out there, we could actually choose the top out of the 99, 100 and scale that one up to the 2,000 or 3,000 model servers that the current champion is holding. So also, we've put quite a bit of emphasis on explainability and tracing, and the ability to explain each and every prediction. So this is really powerful, and we'll show this here in some of the notebooks. Also, I haven't talked too much about Kafka, but I do want to show in a bit here, we do have a notebook that can read into TensorFlow and train from a Kafka stream. So this is really the pathway to the like online training that we speak so much about. So I'll show that here in a bit. All right, so let's head on over. You could either go to this quick start, or if this is kind of the place to start, but if you do want to go directly to the community edition, you can go here. The quick start will actually take you there, so I would recommend starting there. So yeah, let me just put that back there. Just go to quick start. And I'm going to do it myself. So a couple of people raised their hands here. I'm going to get to you folks in a bit. And if you want to actually deploy a model locally, you could follow these steps, the quick start, if you click on Community Edition here, and follow through these things here. And you could actually push out a TensorFlow model. You'll have to create an account with Pipeline, the Community Edition, and then this is just kind of going into more detail about the code, but really it's just a couple steps here. It's just like log into the community, get yourself the user ID, and then you could start to actually optimize and deploy. So I'm gonna do something kind of slick here. Let me go. So I'm in community, and this is like really where you land. If you start from scratch here, you would log in and come to this spot. You can, if you want to, right away choose a sample model. These are all different implementations of MNIST, and we've got 6 of them turned on here. We're working on the others, and we at some point we'll have 16 different versions of the exact same model, or the purpose of the model anyway. These aren't specifically the exact same model. These are TensorFlow version, Scikit version, but I want to show you something cool. So when you could create a project, either you could start with a sample, or you can upload. Even if you follow these steps, you can drag and drop and create a project that way. Or what we're going to do is I'm just going to select, because I've already done this. I did this demo last week in New York for Strata, and so here's 1, 2, 3, 4, 5, 6 different implementations. These are the exact, and now you folks won't see this because you haven't done this yet. You haven't deployed these, but you, if you want to, just go click on each of these and start to deploy all 6 of them, but I've already done it for the purpose of time here. Also make sure rows per page that you're on, there's 1 through 6 here. By default, it'll be just the first 5. So these are 6 different implementations, and I've uploaded these, and I've actually deployed every possible version that we can generate. So if there's GPU versions, we've generated those. If there's any tweaks or any post-training pre-production optimizations, we've applied them, and this is the result. So there's actually 12 variants that we've highlighted here, and you can kind of glean from the names of these what they actually show. So, and I believe they're kind of flipping a bit because it's based on volume. So if you start looking at one, it'll jump. We have to fix that. But for like right now, you can kind of get an idea of the relative performance between these. PyTorch coming in a little bit higher. TensorFlow serving's pretty fast. We actually have a version using TensorFlow Lite. If you search here, so here's Keras with TF Lite, which is actually performing pretty well. And this is also showing, cost per prediction. Now, these right now are pretty coarse-grained values, and they're not exactly correct. We've kind of estimated based on, the instance type. But so don't get too alarmed if you think that each prediction costs 8 cents or whatnot. But like this is one metric that we can tune and actually key off of and start to shift traffic based on this. So right now, I believe I'm connected to an Amazon community cluster right here. But you could actually sort of arbitrage between all three clouds and start to migrate traffic over to the cheapest cloud. So there's different strategies here that we call routing strategies. And when you get past the community version and get into professional and the enterprise, this is where we could start to actually optimize and choose this auto router. So I could say I want to optimize for the minimum latency. And so these are all the different variants. Again, I'm going to drop down to show all of them. We've manually right now seeded with 10% traffic each. And then we could also scale these out. This is kind of hard coded to 10 here for community, just to keep people from getting too crazy. You can also set up auto scaling here, which is nice too. So anytime you hit a particular request queue size, this will actually automatically scale out. And these are the different runtimes. So the first column here is the actual model. And here we're kind of drawing the line at just the actual framework that's used. And then there's the generated runtime. So here's a version of the same Keras model, like you can see by the Git hash there, that this is the exact same Keras model, but now we've got 3 different runtimes. Actually, I think there's even more. There's 4. I think there might even be there's 4 different runtimes here. So CPU TensorFlow serving, GPU TensorFlow serving, straight up Python. That's just calling that Keras model, TensorFlow Lite. And we can, these are all sort of fighting for their position to be the best model for the given goal. And so, this is where we could start to rely on these multi-arm bandits, which can start to shift traffic based on cost, based on throughput, based on latency. There's going to be one more that pops up here in a bit where you can shift across clouds as well. So we're Kubernetes native, so we can run on any cloud right now, or really any environment where we can get to Docker. And so let's see, so here's PyTorch. Also, this is sort of a real-time accuracy here. So this is where, we can, depending on the ground truth that we have that's available to us. And, sometimes determining real-time accuracy involves a Spark job. And so you could really only achieve the 24-hour sort of real-time accuracy. So depending on what your function is to determine this accuracy, this could be a Spark job, this could be a function. One thing I wanted to highlight is everything within the pipeline platform is completely customizable. So this auto scaling, for one example, if you have a custom function that you want to use to auto scale and maybe trigger off of some metric that's specific to your business, you would click new, and then that, so think of this like the classic serverless, function based architecture where you can deploy your own functions and then use those as, part of these customizations. So what was I saying there? Oh, so for the real-time accuracy, you could actually inject your own function, which could be a Spark job. And, of course, coming from Databricks, that's fully supported within Pipeline. The other thing is with this traffic, you could actually route traffic, you could actually mirror traffic, and this will become the default actually. Right now, the default is just 0 traffic, and then you have to go and then manually deploy it. But we are moving to a world where we want these models to go into production as quickly as possible and safely as possible. And so that's the shadowing or the mirroring. And right now, if you select, if we check this will actually turn off live traffic and turn on the sort of best effort mirrored traffic. Now it's saying that we're not at the full 100%, so it's not actually changing anything until we do it. Now it's complete, now it's successful. Now let's go see if this V1 Scikit is still taking traffic, and hopefully it is. And yes, it is. So looks like, yes, even though we've said to mirror traffic, it's not taking this out of service. This is actually putting it into best effort mode. So traffic is being shadowed over here, and it's still showing up in our charts, which is good because we still want to keep an eye on some of these system metrics, and then also, the cost metrics. So I think that's pretty much that screen here. You can also consume these. So there's this predictions tab here where you select, and you could choose any of the different sort of languages that you want to integrate with. You can, from here, like you could actually hit test. There's the results down there. And yeah, so here's, Python integration, Node.js integration. You could grab all that here. This is the start of being able to pass in images, these binaries. Let's go to the next tab. So there's this comparison screen. So, this is all, so you would first deploy, so these models have already been optimized. That was a step that, takes a bit. So I just fast forwarded to my version that already has these. Now these predictions, so predictions are, this here where you could actually test it, but now we want to actually compare these things. So up here we were comparing system level metrics and cost. Down here we're actually comparing now all 12 of these model variants are all predicting the same value for the one input that I'm loading up. So in the background I've got a curl command that's just pounding this cluster. So this is actually comparing for the same input. So this is a single image right now that's coming in, and we just hash it just for the sake of grouping. What we want to do though is show the actual confidence across all those different models. And so here's TensorFlow, here's Python, and we're grouping these. And if there were any outliers, so let's say one of these variants shows up as 5, 4, we can actually drill in and figure out which variants are showing that. And one other thing I want to point out here is when we test, so we're passing in this input. You could pass in, any, so this is a JSON representation of an MNIST digit. Here's the actual prediction. When we do that, let me pull up Slack here for a sec, and I'm going to show you guys something slick. Every time that we do that, we're actually, this is now showing up in a, so right now this is a private Slack channel, but we're actually showing the value, and so the actual image, so this is the input, and then the actual prediction. And so now from Slack, I can go in here and actually relabel this and say, actually that's not a 7, this is a 0, label 0. And this goes back into the pipeline system. We're using Kafka as the implementation detail here. And then Kafka then pulls up and is pulling in this data. So now this is kind of human in the loop. It's not, super scalable because it's kind of human level scalable, but it's kind of nice. And, imagine being able to actually see the image rendering here, which is pretty slick. And then, you as a human can start to grok within seconds or milliseconds here what kind of predictions your model is making. And if you want to, you can correct them, or you could just kind of keep an eye on the stream. So you can build tools around this, you could build apps around this, internal apps, or you could just snap into our Slack support, which is pretty slick. And yeah, people love this. They can, see the inputs, that they could see what the system is predicting, and they can actually fix those predictions right there. And then that data goes right back into the training cycle, and then these models are, being continuously trained and then continuously deployed. Okay, so that's kind of how things flow there. Let me see. There's one more tab here. This is the explanations tab. So here's an example of where we're taking that actual input and we're explaining or making a kind of first attempt here to explain why the system or why these models predicted that digit. And red kind of negatively contributes to that prediction, blue positively, and so sort of pixel by pixel or group by group, you could, or group of pixels, blocks of pixels, you could actually start to to explain or at least, you know, gain some kind of intuition about why that prediction was made. So, and as new models come online, right, like a lot of these models are like open source models, we just pull them right into the platform, or you can inject your own into the platform and actually make these predictions. So again, if you think of the old VEA systems days where was middleware across all, you know, sort of enterprise transactions, now we're talking about predictions, right? Sort of the like middleware for these machine learning predictions, and now you can start to add in different value you know, snippets, and the explanations is perfect. Some of you might be familiar with Jaeger. Jaeger is a way to trace and, you know, not just show performance, but you could actually drill in and see which model variants or models were part of a prediction. And so, you know, this is one single prediction that crossed a couple different models. This is part of the ensembling stuff, which I actually haven't spoken about just yet. But you can see now which specific models or model variants were part of a prediction. And this is really powerful. So not just performance-wise, but you know, this kind of feeds into the explainability of these models. We also have it set up so that models can, if they're taking too long to predict, we can actually short circuit them and continue on if we have a quorum from, you know, 5 of the 7 predictions, then we can move on and keep going. So yeah, there's a lot of advanced ensembling that we've been focusing on. So real quick on the ensemble stuff, I want to point out here that if there were multiple models, which right now there actually aren't, it's just the MNIST project, but let me go in and add one here. I'm going to add Keras model. Let's see, I'm going to call this MNIST A. And let me create another one called MNIST B. Oh, these are actually part of the same project, sorry. I need to create separate projects if I'm going to do the ensembling. So what you could do is you could select the different projects and you would click Ensemble there, and now you can define your own aggregator by clicking New, or select kind of the default aggregators, which are quorum, average, min, max. And if you know, each of these right, like models, once we get quorum, then that's the final model, or yeah, sorry, that's the final prediction. So we'll be building out this more over the next few weeks, and like definitely have an update for you guys in October. Okay, so I'm pulling up the notebooks here, and I want to show you guys some of the newer notebooks that we created just recently. Okay, so want to highlight, let me show you guys. So this is just kind of normal training, training the model. If you drill in, you'll get your own copy of these samples, and you can run through these. But now let's get into the interesting stuff here, which is exporting or sort of optimizing these models and preparing them for deployment. So there's, you know, a couple different ways. You can freeze the graph as kind of the old school way, but you really can do quite a bit when you use the frozen graph strategy, because there's a lot of downstream tools that have been built that are hidden inside of TensorFlow that are slowly making their way to the surface, but not in a very usable way. And so these are the things that, you know, we're actually doing for you as part of the product here and the community edition. So let me point something out here. Let's go into Optimize. So I want to spend a little time talking about TensorFlow Lite. This is an intriguing part of the TensorFlow code base. Not a lot of people really understand this. And we didn't really understand it either when it was first released under different names like TensorFlow Mobile. Others might know this as TF Compile. You know, but this all comes down to the ability to take something, a trained model, and get it into a smaller format or a faster format that's specific to predictions. And that's the space that, you know, Pipeline is focused on, is really, you know, this kind of pipeline to production, if you will. And so the ability to take, you know, different versions of your model, like Keras, like depending on if, how you're actually writing your TensorFlow. If it's low-level TensorFlow, if it's the estimator API, if it's the Keras API, if you're, old school and still kind of like hanging in there with the Slim API or TF layers. As long as you can get these into either a frozen graph, the saved model, which is the middle one, or Keras is HD F5 format, you can then use these kind of hidden converters, right? So this is all just checkboxes from our standpoint when we go to optimize the model. We say, right, like, do you want to use the TensorFlow Lite version? If so, we will generate this for you, and then we will automatically build the TensorFlow Lite runtime for you if it's the GPU version CPU. So this is all. If I go back to the actual app itself, let me show you guys. If I click here, and let's say I click on a model here. I didn't go through this earlier, but this would be the first step. So you would either upload your model through the command line or through the app itself. You can then choose to deploy it if you've configured these different cloud providers or on-prem. You could select CPU, GPU. You could even select TPU. And then you could start to apply, so with different checkboxes, so we can try all 4 of these. These are things that we're going to do for you and make the best effort that we can to generate different variants of your model. And then also, we've put these in human grokable terms, balanced memory and performance, performance optimized. This is really like a lot of C++. Like versions behind here, and TensorFlow serving and similar like libraries to that, and then memory optimized. And this is the sort of businessy version of it, but since we do have a lot of engineers on the call, this is the like TensorFlow Lite and similar types of technologies where we're really trying to get the smallest model. Maybe we are trying to deploy on a small device, or we just want to try out a smaller version of the model and see how the performance is. We would click deploy. All those would get generated and pushed out, and then we could start the load test I'm doing here. Yes, all of the CLI and the base Docker images and everything, this is all open source stuff. If you go through the quick start, you'll see all this. And now we see all these models lighting up here. So, and then from there, then you can drill in and do the auto routing and compare those different things. Okay, so here's more on the so this is what we use during some of our workshops to show people the performance gains. So let me see if this is set up here to run. Interpreter's not defined. Okay, we probably had an error up here. So let me train the model real quick. I don't know if it's been trained in a while. Go through here. So I'm just starting on 01. And you guys should have access to this. We don't require anything. You just got to log in with your GitHub and or LinkedIn or Dropbox or whatever you got there. Next thing, we want to export this so we can optimize it. Convert it into the saved model format. Let's do that. So there's this save model CLI. Now this is more than just a CLI. This is actually a Python library also that can't, but we're showing the CLI here just because that's what we like typically use on like our end. But this is showing the signature for this model. Now this is really important because when you train the model, you need to serve it somewhere. Either give it to Amazon SageMaker, give it to Pipeline, give it to Google Cloud. And they need to be able to inspect this model, or we need to be able to inspect this model and set up the schema and generate the code to like convert from JSON into these tensors or NumPy arrays, whatever you have going on there. Okay, so now we should be able to move here, move pretty quickly. So this is, we're pulling in the TensorFlow, the saved model. We're then kind of looking at it, seeing, oh, and so here we actually generated, okay, so let me go back here. I'm going to show you guys on disk Let me go back to the export. On disk, this model that we train, this is just linear regression, is about 20 plus 4K, so about 20K plus, so about 24K. When we convert this, so now we're just loading it up, we're predicting, this is 12 milliseconds, so I ran through this quickly and now I'm just going back and explaining it. This took 12 milliseconds to make this prediction. And that seems pretty good, and it kind of lines up with what we're seeing, back here. Seems, pretty good. But what we want to do is get that lower. So let's employ this TensorFlow Lite, which most people think of it in terms of mobile and application like mobile development, or like iOS development, Android development. But we're actually using this in the data center, and really to try to get and see how much performance we can squeeze out of this thing. Now, we'll lose a little bit of our final accuracy, but our model started off pretty darn accurate to begin with, 97%, whatever. And now we're just trying to get the best performance that we can. So we convert this into TensorFlow Lite. We get this model down to 688 bytes, and that is compared to the non-TensorFlow Lite, just the regular TensorFlow model of 20 plus 4. So this is a super tiny model, which helps not only from the mobile standpoint for the small device, these sensors and little tiny devices, also makes the math a whole lot faster. And the sort of implementation details behind the scenes are, it's doing some of these optimizations. It's actually, so TensorFlow Lite has its own way of fusing layers and quantizing weights from 32-bit down to 8-bit and that kind of thing. The other example would be if you had TensorRT. So TensorRT actually does its own layer fusing and GPU memory tricks, and so TensorRT is actually a free product from the NVIDIA folks. It's very, very, very difficult to use. It's kind of integrated with TensorFlow, but it's a little bit, it's 2 or 3 generations behind from the main line. And so we're bringing this performance. We're sort of democratizing these AI best practices and AI performance, and just making these small little switches, and we'll do the rest. We'll actually do the C++ compilation and linking and all that good stuff. And all you have to do is just select what you want to try, and then we'll start to actually automate and auto suggest for you which of these to try. We'll take a look at your model, see what you're trying to do, and start to recommend based on your local model versus our global model as well. So that's the ultimate goal there. But for right now, I'm just kind of showing you guys what's possible and where we're headed. So take a look at this. Look at this. This is 33 microseconds. So by converting it down into TensorFlow Lite, this is kind of the finale here. If I scroll up, we did 10 milliseconds, or sorry, it's a user space 12 milliseconds. Somehow wall time is lower. 10 milliseconds. And that seemed really good, but look at this. If we can get down to 30 microseconds, that's orders of magnitude faster, just by running it through this post-training pre-optimization. And for us, this is just one little checkbox. Actually, here it would be just checking this that you want the memory optimized version. Which is actually also acting as a performance boost as well. And when you do that, you'll then want to compare these different variants in production. So that's why we're showing it here, right? Not just the system performance, but we'll also show you, when you go to the comparisons tab, how these models are doing in terms of their predictions. And I mean, down to the actual confidence level as well too. Let me run a couple through here. We don't have them turned on for all requests for obvious reasons, but we would flood the system. But here we're tracking, so down to the confidence level. So we could actually compare side by side. We have some formatting, like UI work to do here, where we make these percentages and show them in a much denser style. But I think you guys get the idea. And then if there's any outliers, for example, if you've turned on the TensorFlow Lite stuff, and TensorFlow Lite version now is predicting wildly out of tolerance, and it's predicting 4 for things that are clearly 7s, then you would want to pull that out of your experiment or shift traffic away from it, or just not, rather make it live. You would keep it in a shadow mode for the duration of that experiment. Okay, let me go back here. So this is showing, this is basically quick start stuff here, how to actually get it into production, how to run the load test here, so you guys can do all that yourselves. Now this is the explanation stuff, and I'm going to jump right to the Keras version here. So let's run through this, and this should actually generate a nice little visual similar to the one I showed you. And this comes from a project called Skater, S-K-A-T-E-R, and behind it, one of the implementations is Lime, L-I-M-E, which is explainability type framework. And so, like, again, we're snapping this into the runtime because we are that like prediction middleware, and so we can now start to add in these little valuable snippets like that. All right, so while that's running, let me show you guys. You could pull from S3, so like this would be more on the training side, or if you're doing batch predictions, you could just give it a bucket as long as your cluster has been configured with the proper IAM roles and policies and all that good stuff. This is a public bucket that we have called Datapalooza, kind of a funny name. And this is, oh, do I have the wrong? Okay, this Kafka one looks like it might have gotten munged. Oh, no, wait, let me see. Yeah, no, here it is. Okay, let me just get rid of, that shouldn't be there. And that shouldn't be there. Sorry, let's see. Just had some extra stuff in my notebook. Okay, so let's just generate some random data, and I'm going to pass this into our internal Kafka cluster, internal, for Community Edition, basically. Every, we're just an instance of the Enterprise Edition, so the Community Edition is our Enterprise with some, features disabled and things like that. So check this out. So we actually put a bunch of data onto our Kafka, and here I'm just namespacing it with the user ID. If you have multiple people working on this, you would want to namespace it that way, or spin up your own cluster, which we're going to be adding that ability within our Streams tab up here. So here we just added a whole bunch of data that we generated up above, and now we're just going to get either one record at a time, and using the Kafka dataset API, or sorry, the TensorFlow dataset API, but the Kafka implementation. So the reason I was showing S3 actually is you could see this is the TensorFlow dataset API, which is TensorFlow's answer to Spark and to ETL, and to improving performance, to getting data into your system for training or for batch inference. And so with the exact same API, you can get data from S3, you can get data from Kafka, and cycle through it multiple times, do what you need to do. So that's just getting a single record at a time. This is actually getting all the records from a particular point in time. But it's all using the exact same API, and it's just how we like initialize this, like using Kafka dataset or the S3 implementation. So you can give it a topic at a time, or and it's handling all of the low-level Kafka consumer like details. We work with the Confluent folks to get optimized versions of Kafka for Kubernetes, and getting all the high availability in place. So right now, by default, when you spin up your own version of Pipeline through either Professional or the Enterprise, you will get a default Kafka cluster that's 3 nodes for the broker, 3 nodes for Zookeeper, and we handle all of the Kubernetes magic beneath the covers, and you can scale that up and down as you need to. Okay, so I think that's it. There's some GPU notebooks in here as well too. I think this version of Community we've got pointing to CPUs only. We do move these over to GPUs and TPUs when we run certain like workshops and campaigns, things like that. So keep an eye out. I think this box does have 4 GPUs. That were, or this like notebook server is on a node that has 4 GPUs, but we're just pointing them to CPUs right now to keep things nice and tidy. So here's some distributed TensorFlow stuff. This is all pretty, boilerplate stuff. I should mention distributed TensorFlow is going through a major overhaul once again. I think it's the 3rd or 4th major overhaul since TensorFlow was first announced, and Keras is now the new place to go. So some of you might be familiar with the Estimator API. The Estimator API is now not the way to go, according to the Google insiders. And as of, I believe it's TensorFlow 1.12, which should be out pretty soon here, the next week or two, you'll want to keep an eye on Keras and start to use the native capabilities of Keras to do distributed TensorFlow. Even today, with the Estimator API, this is still a bit of a pain. And that's the ability to use the exact same code locally on your laptop as in a big cluster or on an infrastructure like Pipeline for the training, or Google Cloud, or SageMaker. So good news there that Keras is the new preferred way to do it. The bad news is not a lot of people are using Keras for distributed TensorFlow, except Google insiders. And so that'll be changing. That'll be a big shift for TensorFlow 2.0 also. We'll be using, and then by default, actually, TensorFlow 2.0 is going to have eager execution. So I skipped over that notebook here, but the ability to sort of run TensorFlow in a line-by-line fashion, like you would, in a REPL or in R, or just regular Scikit, versus the current default, which is lazy execution, which is more like Spark and kind of clunky and a bit difficult to reason through. So the summary here is, in TensorFlow 2.0, eager execution will be on by default. And you don't even have to think about it. Not until you go to productionize your model will you have to think about the graph and all of that. So again, that's also where Pipeline comes in, is to hide a lot of that for you and to take these models that you've trained in what's called eager execution and convert them. One last thing, it looks like I don't have the notebook here, but I want to show, there's this awesome project in the works. I'm in Europe, so I keep getting all these cookie reminders, even though I've already accepted them 1,000 times back in the US. So TensorFlow, so this is a way to take regular Python code and at some point NumPy and Scikit and SciPy and convert it into a TensorFlow graph. And so, this is something to keep an eye on. This is pretty clever. And right now the support's a little bit weak. It supports if statements, which is nice, these conditionals, because this is actually really hard to do within TensorFlow, doing conditionals. And so all you have to do is just import this TensorFlow.autograph and put your little decorator on your Python function, and the output of this will be a TensorFlow graph that you can run within TensorFlow Serving, run on Pipeline, run on these different infrastructures. So the cool thing here is you can start to think, if you do have custom UDFs, user-defined functions that you're using, that you want to import into your TensorFlow code. This has always been kind of a sore point of TensorFlow and Spark, and when you go outside of their world, you now have performance problems. PySpark, even today, it still has issues with this. They've gotten a little bit more compliant and a bit easier to take your current Python-based UDFs or even Java-based UDFs and get them into Spark. And yeah, this is TensorFlow's way of doing it. So this is where you start to see the fact that there are 300, 400 people within Google working on this, and thousands of TensorFlow like contributors. Still these projects do really start from Google, and then they kind of put the anchor down and then build a big community around these things. So yeah, pretty cool stuff here. If you want to, like, you can play with this. I have to build a notebook for this as well too, because it's pretty slick. And so when you inject your functions into Pipeline, we can actually do this for you. And what we're getting at here is there's a new wave we're seeing where companies are taking their Scikit code, and this is actually one of our recommendations. One of our Jumpstart programs is we really work with customers to take an existing model and convert it over. And usually it's a fairly simple model, and it's pretty well known what it's supposed to do. We can take the Scikit model, we can convert it over. Sometimes we use autograph, sometimes we just have to like manually code it within TensorFlow or Keras. And once that model is converted, we then push them both out and compare the performance. And once you can get things into TensorFlow, you now have a whole lot of performance options. You have GPU, you have CPU, you've got all these little tricks, and systems level switches that like you can now turn on. And with the Pipeline platform, you can experiment with all these continuously and safely. Okay, I think that wraps it up. We're at the let's see, it's 7 p.m. Copenhagen time. People are probably going to start dropping off. Let me go back to the slides. So yeah, check out community. Go to quick start PipelineAI, or community.pipeline.ai. And also, if you're in London by any chance next week, or no, sorry, this week, I guess, I'll be there. We are sponsoring this conference, and we have a booth, and yeah, we'll be there, I think, the 20th and the 21st. Also, we have a talk there as well, too, where I'll probably show some of this stuff. This is a glimpse of our vertical banner that we created over the weekend. So, yeah, we are starting to look like a real company, aren't we? Kind of scary. All right, guys. Thanks a lot for joining. And let me double check on the questions here, if there's anything I can answer. People are raising their hands, and I don't know how to call on you or whatever. So if you have questions, yeah, a couple people are raising their hands. So if you have questions, post them in the thing. There's a lot of people on here. Or ping me. Let me see here. So I'll give you guys my email. Chats. Now I can't even get to the chats. Oh, chats are way down here. Okay, here's the questions. Write once, optimize anywhere. I like it. Yeah, if you are jumping into the notebooks halfway through, you'll have to start from the beginning because they actually build on each other. Is there a run all within JupyterLab? So we actually rely heavily on JupyterLab. There's a run all menu option. If you click on run over here, you can click run all, but there's not on the hotkey toolbar thing over there. Let me go back up here. We'll be posting the paper to, I believe it'll be, if you go to pipeline.ai, we'll have all the white paper assets in a few hours here. We'll have the white paper assets. Okay, let me answer a couple other questions. Yeah, Pipeline's always hiring. Shoot us an email, email chris@pipeline.ai for jobs, questions, anything else. Okay, yeah, so Pipeline has open source. If you go to github.com/PipelineAI/pipeline, There's a lot there. You could go to the quick start as well too. I'm just putting all these links in here so others can go to quick start Docker or quick start Kubernetes, and there's ways to get this stuff going yourself. Aggregator, good question on aggregator. So the Ensemble aggregator will combine model predictions at this phase of PipelineAI's development. So we will, someone's asking about the ensembles here. So you'll click Ensemble. Normally there's a bunch of projects here, but you would have MNIST A, MNIST B, MNIST C, these, or, and as long as they are compatible on the inputs, you can have extra fields just as long as these projects or these, models can deal with more data, less data. So there's still there's a tiny bit of, schema design that you have to make sure, because remember, your applications will be calling into these models as though it's the same model no matter what. So, that you have to work with the application teams to make sure, and we help by showing the schema. But yes, we'll actually combine those models in various ways. We're working on a nice visual tool to show and have multiple models predicting in parallel and sort of visualize that. That's all coming. But this is basic aggregations here, but you can introduce your own, and you have full control also. Like you can essentially build your own ensemble through Python and use that as kind of the instead of a visual tool. ODSC West, yes, we will be there as well too. ODSC, we're doing a 3-hour workshop, 3-hour workshop, 3.5-hour workshop at ODSC. So that'll be doing all this hands-on with us right there. And okay, yeah, all the notebooks, and models are here. GitHub.com/PipelineAI/notebooks and HTTPS GitHub.com/PipelineAI/models. Boom. Great questions. Okay, I think that's it, everyone. Do we have random forest models to test? We have XGBoost. I don't think we have a random forest that's committed into our models repo. Do we? I have to look at that. I think we have a Spark model actually, but I don't know if it's out there. But yeah, we could certainly get the random forest one out there. That's a very classic example. Can I run it in my own lab? Can I run my own Kubernetes? You can get pretty far if you follow. So people are asking about Kubernetes. Quickstart.pipeline.ai/Kubernetes gets you the open source Docker images, and you can follow those steps to get it set up, and you can even do some of the routing, the advanced routing there. The traffic routing. And what if I have to write my own code for ML? Can I do that using? Yeah, so someone's asking about if I want to write my own custom code for machine learning. I assume you mean either for training purposes. Yeah, absolutely. This is, you would deploy this or use Community Edition and click on these notebooks here, and you can build your own. You have your own workspace. I wouldn't put anything super duper secure on Community Edition, but yeah, definitely you can get your hands dirty with it there. So custom code, and then also if you do have your own models, you can follow the samples at this is one of the links in here, but github.com/PipelineAI/notebooks. Boom. Oh wait, that's the notebooks. If you want to go to the models, go here, grab one of these of XGBoost, PyTorch, Keras, MXNet, Caffe. You can even build a model in Bash, PMML, Spark models, and yeah, you can get all that stuff in. And we're actually working on kind of bridging to the training world as well too. So right now, you can train and do all you want, or with Pipeline, or you can train somewhere else and get it into Pipeline for the actual ensembling and the optimizing, optimize, yeah, like write once, optimize, and run anywhere kind of thing. I like that. But yeah, we'll be like bridging to the training world here in the next month. We've got some stuff in the works that I'm not quite ready to demo, but we will show very soon, working with some key partners in this space and some new projects. One of which is Kubeflow, but there's also one other project that we'll mention next time as well too. Yeah, models can be text, video, anything that you got. If you're going on the video and the audio route, we would and if you're using text and doing NLP, we would recommend using the GPUs and specifically the Volta V100s, which are have more memory, 16 gigs, and we can definitely get you going on that as well too. So yeah, hit us up at contact at Pipeline or Chris at Pipeline, and we'll get you all straightened out. All right, guys, thanks a lot. I'll be posting this to, I believe it's PipelineAI/community. This video and slides will go to community shortly. Someone's asking about the kind of business overview. And yes, business overview will be posted to pipeline.ai in a couple hours. We actually have the PDF, and we just need to do the last glance. We've already sent it out to specific customers and stuff. So business overview we call the kind of product brief, and this explains the problem. So that's what we'll be seeing here on the site pretty soon. All right, guys, thanks so much. Yeah, hit us up and we'll talk to you soon.